subject aan maanta qaadan doono waa mathematics fasalkana waa form 3 chapterka aan qaadan doono waa numbers. Marka numbers is a broad topic or a wide topic, but in this topic we will discuss sets. Learning outcomes. By the end of the lesson, learners should be able to describe sets in different ways. Describe the different types of sets. Distinguish between equal sets and equivalent sets. Determine the numbers of subsets and proper subsets. Now a set is a collection of objects. A set is a collection of objects. The object or symbols are called elements of the set. Now a set, I said, a set is a collection of objects. The objects can be numbers, the objects can be letters. Now a set of books, a set of pens, a set of numbers, those are examples of sets. Now a set, we have, let's say, whole numbers like 0, 1, 2, 3. These are examples of a set. Now always a set is enclosed with brackets, and the objects which are inside the brackets, we call them elements. We call them elements, or we can call them members of the set. Members of the set. Ways of writing sets. Ways of writing sets. There are several ways of writing sets. There are 5 types of writing sets. One, we have the roster method. Roster method, or this one is also called listing all elements. Listing all elements. Like, for example, let's say we have set A, B, C. Set A, B, C, D. So that is listing all elements. A very good example of the roster method is the class register. When we talk of the class register, names usually start from A to Z. Usually starts from A to Z, but the order is not important. What is important here is the elements should not be repeated twice. So that is one way of writing set is the roster method. Another way of writing set is listing enough elements. Listing enough elements. Enough elements here, I mean, for example, let's say set B contains 1, 2, 3, and so on. And so on. So this is another way of writing sets. You list part of the element instead of writing all the elements. Method number 3, rule number 3 is by description. By description. Another way of writing sets is by description. You describe the set. Describe the set. For example, let's say set A. Set A contains all even numbers. Just write X representing there, and then you write even numbers. Even numbers. So all even numbers will be now inside the brackets. So this is another way of writing a set. Another example is, instead of writing all the names of a certain class, you just say set A contains X representing all the students in Form 3A. So you just write like that. So this is another way of writing. Sets by description. The fourth way of writing sets is known as by algebraic expressions. By algebraic expressions. That is number 4. By algebraic expressions. For example, I want to list all the numbers from 1 up to 1000. So it will be very tedious for me to write from 1 to 1000. What I will do is, I just name that set. Set A is numbers between 1000. You just write X representing the numbers, less or equal to 1, greater or equal to 1, less or equal to 1000. So that is another way of writing sets. Set, the last one, number 5, is set by Venn diagram. We use Venn diagram. Venn diagram. Venn diagram here, this one is, you use shapes to represent the numbers. For example, I draw circles, and then I write the numbers inside the circles. 1, 2, 3, 4, and so on. So these are the 5 different ways of writing sets. Types of sets. Types of sets. There are 3 main types of sets. There are 3 main types of sets. We have A, the finite set. Finite set, this one contains limited number of elements. This one contains limited number of elements, or definite number of elements. Finite means you can count the number of elements in each set. B, we have the infinite set. Infinite set, this one contains a limited number of elements. For example, you can write 1, 2, 3, and so on. So this is our second way of writing, our second type of set. The last type of set is the null set. The null set. The null set, or the empty set, this one means is a set which contains no element. No element. Or empty set. We normally write empty set that way or that way. So these are the 3 types of sets. Exercise now. Example, which of the following sets are empty? Set of counting numbers, set of counting numbers between 5 and 6. So 5 and 6, there is no any number between 5 and 6. So therefore this one becomes an empty set. Set of odd numbers between 7 to 19. 7 to 19, we have 7 up to 19. The odd numbers will be 9, 11, 13, and 15, and 17. So these are the numbers, the odd numbers between 7 to 19. So therefore, this one is not an empty set. Set of set of even numbers which are not divisible by 2. Numbers that are divisible by 2, even numbers which are not divisible by 2. All even numbers are divisible by 2. So therefore, that one is also an empty set, which are not divisible by 2. Okay, the next, equal and equivalent sets. Equal sets. Equal sets. Equal sets. These sets have the same elements. Let's take an example of 2 sets. Set A, which is ABC, and set B, which is CAB. The order of writing the set is not important, so therefore they contain same elements. Equivalent sets have different elements, but they have the same number of elements. So the first set contains 1, 2, 3, 4. The second set contains P, Q, R, S. So therefore these 2 sets are equivalent because they contain same number of elements but different elements. Example, state whether each pair of sets given below has equal sets or equivalent sets. Number 1, 2, and 3, 5, 7, and 5, 3, 7. They contain same elements. So that one becomes an equal set. 8, 6, 8, 6, 3, 6. The first set contains 8, 6, the second set contains 3, 6. So therefore these two sets are equivalent because they contain different number of elements but same number of elements. The next one is 7, 2, 1 and then 1, 2, 7. This one becomes an equal set. Number 4, 9, 17, 25, 2, 9, 3. These two sets are equivalent because they contain a different element but same number. Subsets and proper subset. Now a subset for sets A and B, A is a subset of B if every element of A is also an element of B. This means that A is contained within B. Example, now if A is a subset of B, we write A is a subset of B. A is a subset of B. Example number 1, we have A, B, C. And then B, we also have A, B, C, D, and E. Now A is within B. A is within B. So therefore, A is a subset of B. This is the way of writing a subset. So A is a subset of B. A contains few elements of B, and A is equivalent to B. So therefore, this line means A is equivalent to B. So A, which is A, B, C. And then we have that second circle which represents B. So we say A becomes a subset of B. Subset of B. Subset of B. A is a subset of B. A contains few elements of B, and A is equivalent to B. A is equivalent to B. So that is, A is equivalent to B means when the number of elements in A are also the same as the number of elements in B. So that is A and then B. Proper subset is a subset that is identical, that is not identical to the original set. A proper subset contains few elements. Example, true or false questions. The first one is A is a subset of AB is a subset of ABC. We said that a subset contains few or equivalent to. So therefore AB is equivalent to AB is a subset of ABC. CD is also a subset of CD. They are the same. A is not, because A, that one becomes false because A is not a subset of BC. An empty set is a subset of all sets. Consider these two sets. The sets of all even numbers. The set of all even numbers. B, we have 2, 4, 6. C, we have 2, 3, 4, and 6. Here, B is a proper subset of A, and also B is a proper subset of C. Example, let U be the vowels, that is U, we have A, these are the vowels, all vowels in the English alphabet. So A, E, I, and B, I, O, U, these are proper subsets of the main set, that is U, because they contain few elements. They contain few elements. Example 3, let A be the subset of the letters of the word flow. Follow. Now follow this one. There are several letters that are repeated. So this one, the set becomes now F, O, and then L, and then W. These are the 4 elements. These are we remove the letters that normally repeat because we said that the letters should not be repeated. So find set A. So the set A will be F, O, L, and then W. We remove the letters that normally repeat. The next one is number of proper subsets. Number of proper subsets. Number of subset, or the cardinality of the set, number of subsets is equal to subsets. Number of subset is equal to 2 power n, where n is the number of elements in the set. And the number of proper subsets, number of proper subsets. Number of proper subset will be 2n and minus 1, 2 power n and then minus 1. The first set will be 2 power n, where n now contains 4 elements. So this one becomes 2 power 4, which will be equal to 16. 2 power 4 is equal to 16. You multiply 2 4 times. So this one will also be 2 power n, which is 4 minus 1. So this will be 16 minus 1, which is equal to 15. So this one, the number of proper subsets will be 15, and the number of subsets will be 16. The number of subsets starts from empty set up to the 4 letters or the 4 elements. The number of proper subsets also starts from empty and then up to, there will be 15 elements. I'll stop the lesson here. So I'll request you students to do the exercise on the link below.